In this first example problem, it says, what is yz to the nearest tenth? So we're looking for the length of this side, and it's giving us a little bit of information. It's telling us two angle measures and this side right here. And what's interesting about this information that provided to us, if you were drawing this, if I asked you to create this triangle and I said, okay, one of your angles is going to be 51 degrees, one of your angles is going to be 77 degrees, and then the side that's across from that 77 degree angle will have a length of 7. If I gave you those parameters to make a triangle, there's only one triangle that you could make. If you want to kind of think about why, it would, if I asked you to kind of duplicate this triangle, just to kind of illustrate this idea, and I said, okay, start with a side that's 7 units long. So you started with this side here that's 7 units long. And I said, okay, at one end of that, put an angle that's 51 degrees. I said, okay, so I'm going to put an angle down here that's 51 degrees, right? I'm going to have a 51 degree angle here, but you haven't told me yet how long to make this side. So I'm going to kind of just make it a dotted line that's going to kind of continue on out here for an indeterminate amount of space, right? Because you haven't told me yet how long I'm going to make that, but I do know that that angle is going to be 51 degrees. And then you said, oh, and by the way, somewhere on this side, there has to be a 77 degree angle, and that when that 77 degree angle comes out, it's got to connect with this end right here, the other end of your 7 unit long segment. So if you think about where you could put that 77 degree angle, I could put that 77 degree angle right here, I could put it right here, I could put it right here, right? There's a lot of places that I could have 77 degrees forming this angle between this side here that we don't yet know the length of and this other segment of my triangle, but there's only going to be one place that I could put it so that as it comes up here, it's going to hit the end point of this segment, right? If I look at this one doesn't quite do it. It looks like it's going to hit that other triangle here. Obviously, these two wouldn't do it. They would come up here and they would not hit that side at its end point. So there'll only be one place, maybe out around here, so that if I put that 77 degree angle out here, it would hit the end of this side right here. So just to kind of show you where that might end up being, maybe it's going to end up being right here. So again, this angle here is going to be 77 degrees. And now that we've established where that side, where that vertex will be of the 77 degree angle, we now can kind of say, okay, now we know how long that side is going to be. So we can get rid of all this extra stuff down here, and that side would be like this. So I just wanted to show you that with this bit of information here, that these two angles will be 51 and 77, and that this side over here will be 7, there's only going to be one triangle that you could create. I didn't make my triangle look quite like this one. I think my angle measures are a little bit off, but you get the idea, right? There's only one triangle that would have these measurements, and since that triangle is unique, that means that there should only be one measurement for this side length and only technically one measurement for this side length here. And so what we're going to do in this first example is find this measurement right here. And to do that, we're going to use the law of sines. So the law of sines, if you remember, says that if I take the sine of angle A and I put it over the side length A, it equals the sine of angle B over the side length B, and it equals the sine of angle C over side length C. Now these A's and B's and C's, of course, for certain triangles, those might be different letters. So for instance here we'll have X, Y, and Z instead of A, B, and C. And then the numerators will just be the sides that are across from each of those angles. So let me kind of write this out. In my picture here, I'm going to have the sine of angle X in a numerator, I'll have the sine of angle Y in a numerator, and I'll have the sine of angle Z in a numerator. And then the denominators are going to be the lengths of the sides across from each of these angles. So for instance, what's across from angle X is segment YZ. So segment YZ would go here. Across from angle Y is segment XZ. So I'm going to put XZ down here. And across from for angle Z is segment XY. So I'll put XY down there. Now, this is what I've got written here is essentially the law of sines for this specific triangle, but I haven't actually filled in numbers for any of these measures yet. But I'm going to go ahead and do that now. So I'm going to take I'm going to take angle X, I'm going to change it into 51. I'm going to take angle Z and change it into 77. And I'm going to take XY and I'm going to change it into 7. And then I'm going to identify what's the thing I'm trying to find. Well, it's this one right here. So if all three of these ratios are equal to each other, I can pick out two of them and perhaps cross multiply to find an unknown value. So it should be pretty clear looking at this that I'm going to ignore this middle one since I don't have anything for angle Y or segment XZ. I'm going to ignore that. I'm going to rewrite just this fraction equal to this one. So let's rewrite that. I'll have sine 51 over YZ equals sine 77 over 7. And so again, I just left this middle part out. Now what I can do is I can cross multiply because I only have one unknown in this equation now. This is a proportion with only one unknown. So I can cross multiply to try and solve for that unknown. So I'm going to do that next. I'm going to have YZ times sine 77 equaling 7 times sine 51. And then I know that sine 77 and sine 51, if I type those into my calculator, they're going to give me a pretty wacky decimal. It's going to take up pretty much the whole screen on my calculator. So instead of doing that now and having to keep track of this long decimal through the rest of the problem, I'm just going to leave these amounts written as they are now, sine 77 and sine 51. And I'm going to take one more step to get this YZ by itself. I'm going to divide both sides of this equation by sine 77 so that it cancels out right here and I have YZ by itself, and that's going to be equal to 7 times sine 51 divided by sine 77. And now is when I'm going to grab my calculator and I'm going to type 7 times sine 51. I'm going to get that amount and then I'm going to divide that amount by sine 77. So I was just doing that on my calculator off to the side here. And what I end up with is I get an answer that's about 5.6. It technically I think comes out to be 5.583116648, but it says to round to the nearest tenth, so that amount rounds to 5.6. Now in the second triangle, you're going to notice that we have, or the second problem, we have the same triangle. It's the identical triangle, only now we're looking for this side right here, XZ. I'm going to write that this side over here was about 5.6. That's what we found in the last problem. And I'm going to rewrite that law of sines relationship for this picture. So remember it said sine 51 over YZ, which I'm going to say is about 5.6, equals sine of angle Y over XZ equals sine of angle Z, which is 77, over segment XY, which is 7. So this is my law of sines relationship for this problem. Again, I filled in the 5.6 with what we found in the last problem. And now we're looking to find the length of XZ. And initially it seems like I have a problem, because if I want to find the length of XZ, it means I want to use this middle ratio, but I have unknowns in both the numerator and the denominator. I'm going to have, doesn't matter if I pick these two ratios to make a proportion, or if I pick these two to make a proportion. Either way I go, it seems like I'm going to have two unknowns. Except if I remember that all three of these angles have to add up to 180, which means I should be able to actually find the measure of angle Y and change that into its measure. So let's do that real quick. Over here I'm going to say that the measure of angle Y plus 51 plus 77 needs to equal 180. So the measure of angle Y is just 180 minus 51 and 77. So 51 plus 77 is 128. So the measure of angle Y is 180 minus 128, which is going to be 52. So now up here I can put a 52 for the measure of angle Y. And I can just go ahead and now I'm going to pick these two ratios. And the reason I'm choosing these two is I just want to make sure if, in the event that I got this problem wrong, the 5.6, I don't want to use that again to find another value, because if this is wrong, then I'll end up with a wrong answer here. So I'm going to use these two ratios since I know that the 77 and the 7 are correct because they're just given information in the problem. So I'm going to have sine 52 over the length of XZ equals sine 77 over 7. Then I'm going to cross multiply and get XZ times sine 77 equals 7 times sine 52. Then I'm going to divide both of these sides by sine 77 so that it cancels out on the left and I have just xz. And then I grab my calculator and I do 7 times sine 52. And then I take that amount and divide by sine 77. And I get a value of about 5.7 in this case. So my length of xz is about 5.7. Now I might want to double check here and just see if this makes sense, right? And then what I mean by that is if I look at these three angles, this is the smallest angle, this is the biggest angle, this one's in the middle. From what we learned before, if this is the smallest angle, then the side across from it should be the smallest of the three sides, which it is. If this is the biggest angle, the side that's across from it should be the biggest of the three sides, which it is. And then the middle angle should be across from the middle side, which it is. So I can kind of check myself there to see if my answer makes sense. Now we're moving on to the last problem for the video, and what you'll notice is in this problem I'm looking for an angle measure instead of a side length. The last two problems were looking for a side length, but now I'm missing the two angle measures in my picture here. But I'm still going to use the law of sines. So again, I'm going to write out my law of sines for this picture here. The sine of angle M will be across from the length of ON. The sine of angle N will be above the length of segment MO, and then the sine of angle O will be on top of the length of MN. So this is just the sine law applied to this picture with the, using the letters that are used for the corners of this triangle's name. So M across from ON, N across from MO, O across from MN. Now I'm going to fill in amounts that I have for this picture. So I have angle M at 70 degrees. I have length OM or MO as 2 and ON as 4. So now if I look here, I think I can right away maybe just use these two ratios to find angle N, right? Because if I use these two ratios, I will only have one unknown. I'm going to ignore this. I'm going to rewrite sine of 70 over 4 equals sine of angle N over 2. And then I'm going to cross multiply. So it's going to give me 2 times the sine of 70 equals 4 times the sine of N. Then I'm going to divide both sides by 4 so that I have 2 times sine 70 over 4 equals sine of N. Now I need to get rid of this sine, and if you remember, the way we get rid of sine, or the way we get rid of cosine, the way we get rid of tangent that's in front of a variable that we're trying to find, is we use the inverse of that function. So I'm going to use the inverse of sine on this side to get rid of the sine that's in front of my variable. But whatever I do to this side, I got to do to this side over here. So I'm going to use this space to kind of show you what I'm going to do. I'm going to take the inverse of the sine of N. And I'm going to take the inverse of everything that I have over here. So it's going to get kind of messy with what I'm writing, but it's going to say 2 times sine 70 over 4. I'm going to take the sine inverse of that. Now by doing sine inverse, it cancels out the sine that's in front of N. So my N, the value of that angle, the measure of that angle, is whatever I get when I do the sine inverse of all of this. So I'm going to now grab my calculator, and I'm going to figure out what 2 times the sine of 70 divided by 4 is. So I'm going to take 2 times sine 70, and that's going to give me about, so that numerator is going to come to about 1.8794. Then I'm going to divide that by 4, and I'm going to get, so I'm going to rewrite here. I'm going to now be taking the sine inverse of about 0.4698. So this is 0.4698. That's what I got when I did 2 times sine 70, which was this, and then I divided it by 4 to give me this. I'm now going to take the sine inverse of that amount. So second sine on my calculator of this 0.4698 value gives me a measure for N of about 28.0 degrees. So the measure of angle N is about 28.0 degrees. Then I have to find angle O, but the good news is it's going to be pretty simple. Since I already know what that angle and now I know what that angle is, I can just find angle O by saying that the measure of angle O plus 70 plus 28.0 should equal 180. So that the measure of angle O is equal to 180 minus 98. The 98 is just these two combined together, which is going to be about 82 degrees. So angle O here is about 82 degrees.